I am excited to be upgrading my Pi1541 to a 3A+. Today on Basic Bytes, I will be talking about why I am making the change in hopes of giving you some good information about what makes the different hardware versions, well, different. And, as a bonus for those of you who are tired of having custom 3D printed cases cost more than the device itself, I have also found a sleek designer case for the Pi 3, which is fully compatible with the Pi1541 hat for about $10. Greetings, it's JC at Basic Bytes, and you know, I absolutely adore my two original 1541 Mark II disk drives that I still have from my original dual drive Commodore 64 setup that I ran back in the day. At present, I only have one of them in active service, and that is to accommodate my still existing collection of several hundred floppy disks that go along with it. As a Commodore 64 enthusiast in the modern era, my primary disk drive is, of course, a Pi1541. Since you are watching this video, you probably already know that the Pi1541 is the brainchild of Steve White and is a cycle-exact emulator for the 1541 disk drive, and presently also has partial 1581 emulation support as well. As we know, the 1541 disk drive was a 6502 microprocessor-controlled computer independent of the Commodore 64 with its own RAM and ROM. The Pi1541 as a cycle-exact emulator doesn't merely read and write in the 1541 file format, but using custom firmware running on a Raspberry Pi board actually simulates the microprocessor and related I/O chips that exist inside a physical 1541 disk drive. This, combined with the ROM code from the 1541 model of your choice, will enable the Pi1541 to communicate with your Commodore 64 exactly as a real disk drive would, enabling such things as fast loaders that depend upon the ability to execute code on the drive itself. And in regards to the ROM revision, of course, I would recommend using the one from the 1541 Mark II, as several of the previous 1541 ROMs had some potentially disastrous bugs in them. In the remainder of this video, I will not be discussing how to set up or configure the SD cards to run the various Pi1541 models, as there is already plenty of reference information about that online. Rather, as I talk about my upgrade from the Pi 0 to a 3A+, and the reasons for it, I will be focusing on the hardware differences, as there are differences between Pi models and between Pi1541 hats that may be better or worse for you, depending upon your use case. Let's take a look at the hardware that I'm using presently, because this is more than a Pi1541 This is actually a Pi1541 and Epix Fastload combination cartridge made by Remzi 64, who makes all sorts of interesting peripherals and devices for the Commodore 64, sells them on eBay, and actually has a YouTube channel where he shows off whatever project he's planning on bringing to market next. It's actually only the upper portion of this board that is the Pi1541 portion, and the lower half is the ROM and chip for an Epix Fastload cartridge. And if we flip it over to the back, this here is the Pi1541 board, which I have backed with electrical tape to stop it from grounding out on anything, and it is firmly attached to the cartridge with some nylon standoffs. If you were to simply buy a Pi Zero hat, it would be about the size as the upper portion of this board. However, if you are going to invest in the Pi Zero version, I suggest that one of these combination cartridges is the best way to go. What with the Pi Zero being less than $10 and this giving you the Pi1541 hat and an Epix Fastload cartridge for, I believe it was under $50 at the time that I got it. The flexibility of this particular device is that it by no means needs to be powered off the cartridge port. If you wish to use a cartridge other than the Epix Fastload, you can simply power the Pi1541 by connecting an external power supply to the micro USB port on the Pi Zero, noting that you should never connect both power sources at the same time or very bad things reportedly happen. Using external USB power will become mandatory with my upgrade to the Pi 3, but that's typically how I have to power my Pi1541 anyhow, since the majority of the time my expansion port is, of course, occupied by the final cartridge 3. Don't program without it. Nonetheless, as the owner of several Commodore 64s, having the Epix Fastload on board makes this highly convenient to plug into any of the secondary machines that I might be working on and know that I have a fast-loading 1541 disk drive without having to worry about how to power it. For all its advantages, there are several disadvantages to both the Pi Zero version of the firmware as well as this particular version of the hardware versus the ones that I am upgrading to, and that's our next subject. Time to talk comparisons. I've already sung the praises of this particular Pi1541 model. Now it's more so time to find out where the Pi 3 version shines. There are two layers to this. Firstly, there is what is supported by one version of the firmware that the other does not, and the second is what is supported by one version of the hardware that the other does not. Speaking first about the firmware, it is coded and released centrally by Mr. Steve White, and therefore it is consistent across the board regardless of whose Pi1541 hardware you may choose to purchase. The kernels are Pi specific, and since the Pi Zero has far less processing power than the Pi 3, its kernel has several features disabled. As an investment, the Pi 3 may have longevity on its side, given that the gap between the features supported by the Pi 3 and those supported by the Pi Zero could presumably continue to widen as the Pi1541 firmware continues to be developed into the future. Especially considering that even with the current feature set, it is recommended to slightly overclock the Pi Zero in order to achieve good performance. At the same time, no one knows exactly what the future of the project holds, and there are already examples of features that once only worked on the Pi 3 that have since become available on the Pi Zero. One such feature is the little buzzer that provides audible feedback whenever you would hear an actual 1541 head-stepping between the tracks, and I have already seen versions of this cartridge that do contain the buzzer on board. At the present time, it appears that the two main limitations of the Pi Zero version are that you cannot hook up an external HDMI monitor to, well, monitor your Pi1541, nor can you hook up a USB keyboard in order to control your Pi1541. I will say forthrightly that neither of those features in any way inspired my upgrade today, as I have never had the desire to allocate another half a desk so that my disk drive can have its own keyboard and monitor. Personally, I find that the control buttons combined with the OLED screen on the Pi1541 itself provide all of the control and user feedback that I need. Nonetheless, those features do have their place and may be of interest to some of you out there. Now it's time to talk about what's driving my upgrade, and that is hardware. Hardware being the Pi1541 hats that you buy, which connect to your Raspberry Pi and provide you the various screens and buttons and ports and things that you will need to physically operate and receive feedback from the device. Pi1541 hats are designed, built, and sold by a whole variety of individuals and companies, but they are all based upon schematics on the Pi1541 website, and thus all Pi1541 hats can be distilled down into two general hardware categories, Option A and Option B. What's the difference? It's a big one, and in this particular case, it translates into portability versus expandability. Looking at the back of any Commodore peripheral, such as this 1541-2 disk drive, you generally see two IEC serial ports. The Commodore serial bus, as you may already know, is a daisy chain, so you plug the serial cable from your Commodore 64 computer into either of the open ports in the back of your disk drive, and then the free second port can be used for another serial cable to chain to the next device, and the next device, and the next device. And as long as all of your devices have their own unique device number, everything on the chain should function properly. Looking at these Pi1541 hats, which represent Option A and Option B hardware, you will clearly see the presence of two ports on the Option B. However, the Option A only has a single IEC connector, which makes it quite difficult to plug this device into a daisy chain with other peripherals, and that is entirely deliberate. The A version of the Pi1541 hardware is not meant to be plugged into the Commodore alongside any other serial bus peripherals, as that can, may, and probably will eventually fry your Pi. There are some makers who simply say to limit the amount of other peripherals if you have the A hardware, and or to simply make sure that the Pi 0 is the last thing on the serial chain. However, the official word is that if you are using the A hardware, it is intended to be the only thing on the serial bus. Whereas, if you are using the version B hardware, it can be chained presumably with as many other peripherals as you want, just as the original Commodore peripherals could be. I will try to give a semi-technical, semi-layman's explanation for this without getting too far into the weeds. You'll notice that both version A and version B hardware have this little level shifter board on the PCB. That's because the Commodore serial bus, being a previous generation of technology, runs on 5 volts, and the GPIO bus on the Raspberry Pi, being new generation technology, expects 3.3 volts. So these level shifters convert those voltages back and forth between what the Raspberry Pi runs on and what the Commodore 64 runs on. So far so good, but the problem is the more devices you add onto the daisy chain, the more chatter there is coming down the serial bus more frequently. And on the A version of the hardware, it's actually the level shifter and the I/O bus on the Raspberry Pi itself that has to filter out all that traffic, and at a certain point of load, it simply cannot cope with all the traffic from all the devices coming down the pipe, and reportedly will ultimately fry. The reason why the B hardware is not susceptible to that is because it contains this additional logic chip right here, which the A version does not, bearing in mind that you must ignore this chip down here, as that is part of the Epic's fast load cartridge and has nothing to do with the Pi1541 section. This is a 7406 logic chip, reportedly the same or similar as exists in actual Commodore peripherals. On the B version of the hardware, lines from the serial bus are actually routed via that IC, thus taking the load off the Raspberry Pi's GPIO bus and the level shifter. And being that this is an old school 5-volt IC, it can handle 5-volt serial traffic all day long without an issue. So let's take a bit more of a look at the new Pi1541 hat for the Raspberry Pi 3A+, which is here for now as set dressing. It's important to know going in that this Pi1541 hat was not designed by the vendor who built and sold it. Rather, this is the Pi1541 I/O adapter designed by hackup.net, and the files for it are available on their GitHub in case you wish to have your own PCB made and build your own, although there probably isn't a lot of economy in time or money doing that if you only want a single device. This is a revision 5 Pi1541 I/O, which is the latest revision as of the production of this video, although interestingly, if you go to the GitHub page for this project, the main README file only displays and documents the differences up to revision 4. Having done some visual inspection, it appears to me that the only differences between revision 4 and 5 is perhaps that some components have been slightly moved around on the board to put them in a more convenient location. However, if you know of any other differences between revision 4 and 5 that I am unaware of due to the seeming lack of documentation, by all means, leave me a comment, as I would be rather interested to read it. Given that this exact board is assembled and sold at a variety of price points by a variety of vendors in a variety of locations, it is rather easy to see who is skimping and who is going the extra mile, and I'm pleased to say that it appears this vendor is very much in the latter category. This is probably a good time for me to state that this video has no sponsors or affiliates, and all product commentary contained throughout is simply me giving my opinions as a customer. This particular hat was assembled by and purchased from Retro Computer Store, who do have their own website. However, this one was purchased off eBay, username RC_Benzion, who I believe is also the same as 8-Bit Phoenix on Etsy, if you prefer that storefront. In any case, all of the products and photos are the same, so I believe that's a logical assumption to make. This product sold for what I considered to be a very reasonable price, shipped well packed, was enclosed in its own static bag, and seems to be well assembled. The brass standoffs were included and came pre-installed into the four corners. The OLED screen was not soldered into the board, but shipped in its own separate jewel box. On the board is a pin header which allows you to plug in the screen directly, or if you are building your own enclosure, you can then run a short extension that will allow you to put the screen wherever you want it. Furthermore, the logic chip was socketed. Many makers would not consider a socket to be necessary, since presumably you are only replacing the logic chip in the event that it gets fried by electrostatic discharge or some such thing. Nonetheless, a socket was included for this one, just in case. Speaking of the logic chip, it is important to know that you are purchasing from a vendor who is sourcing quality parts, such as this genuine branded Texas Instruments chip. Cheap, generic chips, as well as knockoff fakes from less than reputable sources, can lead to problems with your Pi1541. One minor change that I might make to this board in the future is regarding a small jumper in this corner that enables the speaker. I may, at some point in time, desolder that jumper and replace it with a pin header for a removable jumper, thus allowing me to enable or disable the speaker at will. It's almost time to put the whole thing together, but of course you're going to want a casing to protect your Raspberry Pi. When I saw the one that's in here, I thought, firstly, I want one. Secondly, I want to show that off on the channel because not only do I personally think that it's a very neat artistic concept, but it isn't all that often you actually find a Pi case that is sleek and budget conscious and specifically designed with the idea in mind that you will be attaching a hat onto your Raspberry Pi, and this one checks all three of those boxes. This is the Pibow Coupé case, which isn't a box for your Pi, but rather a series of precision-cut plexi layers which sandwiches around it. The Pibow is a product of Pimoroni.com, who are a UK storefront. However, I bought this one right here in Canada for about $10 from PiShop.ca, who, at the time I purchased my Pi Zero, were buyapie.ca, so they have undergone some minor branding changes, but are still much the same website. And here is a close-up of the Pibow stack with the Raspberry Pi 3A Plus inside for reference. This is the Coupé Ninja, which refers to its smoked gray and clear plexiglass color scheme. You are seeing the clear layer as white because there is a protective backing that I have not yet peeled off, although I rather like the look of it this way. I personally favor the aesthetic of the Commodore 64C. However, I noticed on Pimoroni.com that they also have a Coupé Rainbow, which is exactly what it sounds like. My immediate thought was that it might appeal to those of you who are fans of the older brown-beige rainbow-badged breadbox Commodore 64 aesthetic, since its color scheme would directly complement one of the design features of your hardware. In any case, you will take note here that clear allowances have been made for the attachment of a Pi hat and its 4 standoffs, and in addition for a heatsink on your Raspberry Pi, which is certainly recommended. And there she is, my new 1541 drive for my Commodore 64 and 128. All that's left for me to do is put in an SD card, and this time around I've opted for an 8GB Sandisk industrial SD card versus the 16GB Sandisk Ultra card that I've been using in my Pi1541-0. Notwithstanding that the other card has been performing flawlessly, the industrial series of cards is supposed to be an even further investment in quality over quantity, and that certainly makes sense for a device such as this, considering that on an 8GB card you can have anywhere from 25,000 to 50,000 disk images, depending of course on whether they're in D64 or G64 format. And if you find my format to be interesting or entertaining, please like and subscribe to Basic Bytes for more. You can also find us at basicbytes.ca. Thank you for watching.